We're done with this one, so 38, now we continue with 40. Okay, we have 40, 42, and 44. Ready? So the square root property, we know what to do, so please stop me when you see a problem that you would like to work on. They're all with the square root property, all of them. You could choose any problem. But this is complete the square already. So let's go back. Any problem, one more time, from here. This one, this one, this one, this one, this one. Which one?
Number 4.
We want number 4. Number 4 it is. This one? Perfect. So we have x plus 3 squared equals -4. Perfect. I copied it. So now let's take a look. We apply the square root to both sides. It's already set up. We write x plus 3. We have to write plus or minus. Remember, whenever you take the square root, you have to write plus or minus. And now let's identify what do I replace, or how do I simplify the square of -4. It's, yes, 2i. All I have to do is subtract 3. And it's done.
So if the question were find all real solutions to the question, then it will be the empty set?
Yes, in this case, the solution set is not a real number. Because if you graph this function, you will see is way above the x-axis. It does not touch the x-axis. So the solutions are imaginary. So are we comfortable with taking square roots? Can we look at to complete the square now? Yes? Okay, perfect. So let's continue.
I reviewed the last video that you had the day was unsafe.
Yes?
So it's going to be very hard on completing the square.
Complete the square, yes. I totally disagree with it as being a method of solving quadratic equations because it alone cannot do the job.
I get that part, but it seems like completing the square, isn't it the father of the quadratic equation?
Yes, it is.
So you can't really,
The quadratic formula.
the quadratic formula.
It is. I agree. And the vertex as well. That's how you complete the square, to find the vertex. And so, yes, I completely agree. But I think that it's a more useful method, or it's better to be presented when you talk about conic sections. A lot of the students do not get to conic sections, other than the circle, right? But you don't get to hyperbola, the ellipse, the parabola. That is not a function, right? So I have mixed feelings about it. I always present it when I needed it later on, because students don't remember it. So whenever I get to, let's say, pre-calculus with the conic sections, ellipse, hyperbola, parabola, I present it from scratch. Okay, so moving on to, let's take a look at the complete the square. This is still the square root property. Okay, so solve the quadratic equation by completing the square. Yes, it's possible. It's a legitimate method. I just think that it's too much at this level when we should worry about other things, I think, more than complete the square, but that's fine. Okay, so x squared minus 2x equals 6. So remember the four-step procedure. First, we have to make sure that the quadratic equation or the polynomial is presented in descending order. Yes, the polynomial is in descending order. If 6 is on this side or on that side, it doesn't matter. We can move it later. If it's on the right, if it's on the left, we can move it to the right later. Now we have to identify the middle coefficient. We take the numbers with the sign in front. So the middle coefficient is -2. In the next step, we have to divide -2 by 2, and we get -1. In the next step, we have to square -1. When I square -1, I get 1. This is the number that I need to add to both sides. So I have x squared minus 2x plus 1 equals 6 plus 1. Please make sure that you add it to both sides. This is mandatory. And now the left-hand side is a perfect square. But what perfect square is that? Can anyone give us the perfect square on the left-hand side?
X minus 1 squared.
Very good, awesome. X minus 1, everything squared, and that equals 7. Okay, now if I don't remember how to continue, I may be tempted to expand and move 7 to the other side, etc. But no, this is done. X minus 1 equals plus or minus the square root of 7, so x equals 1 plus the square root of 7. And on paper, you do not have to separate those, because you cannot further simplify.
So again, if on the right side of the equation you got a negative number, then you're going to have
A complex, yes. Yes, imaginary solution, that's correct. Do we need another complete the square? Yes, or we move on?
Move on.
Thank you. Are you okay? Everyone okay? Morgan, are you okay? Yes. Okay. So we still have complete the square, complete the square, complete the square. Okay, that's it.
Pearson goes crazy with me sometimes.
Yes, of course. It's tremendous amount of work, especially when the leading coefficient is not 1.
Yes.
Once we have the quadratic formula, and we can get the solution in 30 seconds. But I understand why it's important and it's useful. Okay, 42. Moving on to 42. Okay, so let's take a look at any problem with the quadratic formula. Let's choose. So this is number 7, number 8, number 9, number 10, number 11, 12. Any equation, so we can practice the quadratic formula with. 8, very good. So let me go back to 8, here it is, 8 it is. 2x squared equals 2x plus 3, very good. Perfect pick. So I'm given this equation, it's quadratic. I expect 2 solutions, real or imaginary, I don't care, but 2 solutions. I have to move everything to one side. It has to be in descending order. 2x squared minus 2x minus 3, mandatory. And now, let's write the quadratic formula to refresh our memory. It's negative b plus or minus b squared minus 4ac over 2a. And now, carefully, I plug in A, I plug in B, and I plug in C. So then x equals negative b, 2, plus or minus b squared, 4, minus 4, times A times C, times 2, times negative 3, but I have 2 negatives, so I'm going to just simply change that into a positive. Over 2 times 2, which is 4. Because otherwise I will have to use a lot of nested parentheses. So here's what I recommend. Let's put this in the calculator from the beginning. So let me see, 24, 28, yeah. So we can create a simplified form, and we can also determine the approximate solution. I'll show you both. So first, let's find the exact. Okay, the exact will be, without disregard parentheses. For the exact, we don't need those parentheses. 2 plus or minus. So 4 times 2 is 8. 3 times 8, 24, right? Plus 4, 28. The square root of 28 divided by 4. And I have to present the square root of 28 as the square root of 4 times the square root of 7. So then this is x equals 2 plus or minus 2, the square root of 7 over 4. Do not simplify like this or like this. What you can do is factor out 2. That you can. And now you simplify only factors. Or separate the fraction. It's up to you. So then x equals 1 plus or minus the square root of 7 over 2. And that's the final simplified form. With a calculator, if you're interested in determining the approximation, you will put parentheses around the numerator. Do not perform operations step by step. Please put everything at once. 2 plus the square root, parentheses underneath. I have 4 plus, we already calculated that, but let's say we didn't. Get outside of the radical, put parentheses, divide, and put 4. Then you copy everything you entered by second and entry, and you just go back and overwrite plus into a minus by a minus. And these are the approximate solutions. So one solution is 1.82 and the other one is negative 0.82. Oh, actually, I'm sorry, I just wanted to continue. So this is how we use quadratic formula. And there is nothing else. So now we can move on to the last. They're all the same. Make sure you put them in descending order. Make sure you set it equal to 0. If the equation is not set equal to 0, and you do not have the left-hand side in descending order, you cannot use the quadratic formula. Careful. Because you will not correctly identify A, B, and C. Okay, so let's look at these two word problems. Okay, so let's read the problem. In a round-robin chess tournament, each player is paired with every other player once. The function shown below models the number of chess games n. So n is the number of games. Okay, that must be played in a round-robin tournament with T chess players. T players. Perfect. In a round-robin chess tournament, 55 games were played. So n equals 55. How many players entered the tournament? So I copy the formula. N equals t squared minus t over 2. So we are told n equals 55, and the question is find t. So all I have to do now is replace n by 55. So t squared minus t over 2 equals 55. We will have to get rid of the fractions. So we have t, we multiply everything by 2. So t squared minus t equals 110. So now t squared minus t minus 110 equals 0. You can factor, but let's say we use the quadratic formula or we factor. It's up to you. Not difficult to factor. So t minus 11 and t plus 10. So we get t equals 11 and t equals negative 10. But since t is the number of players, what will you say? In the round robin, we have 11 players. Any questions?
Yes, for the last problem that we didn't do the quadratic formula.
Yes?
We didn't do a sanity check to see if the answers were make sense.
That's true.
But it wasn't a real world problem either. So
yes, that's true. We should have done that. I can do it. So here's how we do it. Very good question. And where is the equation? Let's go back. So the equation is it's a very good question actually. Which of the two we would like to check? I like to check the last one. Here's why. Because I can put in the equation and I can recall the answer. So 2 multiplied by x, in parentheses, multiplied by the previous answer squared. And then minus 2 multiplied by the previous answer, and then minus 3. When I hit enter, if the answer is correct, what should I get? Nada. Okay? Very good. Very good question, Bob. Thank you. Good. So where are we now? Okay, last problem here, and then one more section. Oh, what am I doing? Yes, I'm doing it. That's correct. So the bar graph shows the number of fatal vehicle crashes per 100 million miles driven for drivers of various age groups. The number of fatal vehicle crashes per 100 million miles, N, for drivers of age X can be modeled by this. According to the formula, what age groups are expected to be involved in 3 fatal crashes per 100 million miles driven? So one more time, N is the number of fatal vehicle crashes. X is the age. According to the formula, what age groups, meaning X, what X should be, if they are involved in 3 fatal crashes per 100 million miles driven. I will have to replace N by 3. And we get 0.014x squared minus 1.19x plus 28.23 equals 3. Of course, this is not factorable. And if it were, I wouldn't even try it. I will have to have it set equal to 0. So 0.014x squared minus 1.19x plus 25.23 equals 0. And then the quadratic formula, 1.19 plus or minus the square root of 1.19 squared minus 4 times 0.014 times 25.33 divided by 2 times this, 0.028.
Question.
Yes?
Would it be possible to multiply everything by 10 to get rid of those messy decimal numbers?
Yes, you could. But still, you need 1,000 to eliminate all of them.
At least you'd be dealing with whole numbers.
Yeah, that's fine too. Okay, let's see what we get. So please put everything in the calculator at once. Do not solve step by step. And don't forget parentheses, because if you forget parentheses, the calculator will not do what you want the calculator to do. So then plus the square root in parentheses 1.19 squared, and then minus 4 times 0.014 times 25.33. Close the parenthesis, go outside of the square root, and divide by 0.028. Thank you. Let's take a look at the problem again. The number of fatal vehicle crashes, N, for drivers of age X can be modeled by, according to the formula, what age groups are expected to be involved in 3. So, now I'm looking and make sure that I copied everything correctly. 0.014x squared, yes, minus 1.19x, yes, plus 28.23, yes, equals 3. Okay. I'm checking now my,
I think you have 1.19 outside the parentheses. So it should be 0.14, right? No.
it's negative b,
Okay. Oh, okay.
plus or minus. I'm going back to check. You may see something I don't. It's very possible. So negative b plus or minus b squared minus 4. So I subtracted 3 from both sides. So it's 25.33 minus 4. Negative b. Is that negative? Maybe it's, is it positive? It doesn't make a difference. Yeah, 0.14. Yes, I think I copied everything correctly. Okay, so negative b plus or minus b squared minus 4 times a times c. But I see why that quantity is 4 times 25, and this is so much smaller.
Maybe the math got the error.
No. So n,
It's 3. Subtract.
so no, it's something to do with the measurement unit. Let me think again. So the bar graph shows the number of crashes per 100 million miles driven for drivers of different age groups. The number of fatal vehicle crashes per 100, okay, so that's n. 3 fatal crashes per 100 million miles driven for drivers of age X can be modeled by the following formula. I think they have an error,
I
possibly.
think so too.
Instead of 1.19, I think it's 11.9.
Something like that, right? Because with b squared minus 4ac is negative.
Right.
Right.
So I'm going to give it a shot and change it into minus 11.9 and see what that will change. So I'll change this into 11.9. 11.9, 11.9, and here 11.9. Let's see. Okay, so go back to, something is wrong with their formula. But I'm glad we discovered it before you go home and, okay, so I will copy everything and make the necessary changes. And now the denominator stays the same, yeah, okay. So I'll change this and I'll insert a dot here. Then I will change this and insert a dot here. Let's see what happens now. Of course, that's not possible. Oh, I thought I changed it. I changed it the front. It doesn't. It didn't. Okay, I'm just going to start from scratch. So 11.9 plus the square root 11.9 squared minus 4 times 0.014, or maybe I missed a 0 in there. 0.014, no, I don't think so. Multiply by 25.33. Close the parenthesis under the square root and go outside and divide. Oh, don't forget parentheses outside. And then divide by 0.028. No, there must be a mistake. It's not that. It's not what I was expecting. But it's not possible. So for 3, for 3, it should be 45 years old. So I can, according to the graph, but the formula doesn't give me that. And it's not, it says use a comma to separate answers. So it's not just 45. At the age of 45, and I don't know what other age group would have that. I don't know, 65. Maybe if I just put 2 numbers in, it gives me the solution and see what they. Yeah, I know. Thank you. I do know that. So 45 is one of them for sure. Yeah. Okay, so this is what we did. We wrote 3 equals this. Continue. Okay, fine. Yeah, that would be 25.23.
Right.
Okay, I enter your answer. Okay, thank you. Yes, go on. Yes, I know that A is 0.014. Okay, yeah. Thank you. And then I know that B, yes, I know, B is negative 1.19. Yes, thank you. Awesome. And yes, I know that C, yes, I know, it's 25.23. I did write 3 in the formula, however, by mistake. But can that make such a big difference? Okay. 1.19 plus the square root of 1.19. It cannot be. Minus 4 times 0.014 times 25.23. Close the parenthesis and close the parenthesis for the top. And then divide by 0.028. Ah, I think I was missing a parenthesis. I think I was missing a parenthesis, so, yep. So then I was missing a parenthesis somewhere. Okay, so it is this. 1.19 squared minus 4 times 0.014 times 25.23. Yeah, I was missing a parenthesis somewhere. So we get that x equals 44.5, which is 45, which we knew from the table, from the bar graph. But now I have to determine the other one. And here's what we do with the other one, second and entry, and we go back and we replace the plus in front by the minus. This one here. This one. No, not there, but here. Okay. So it's 40.47. Okay. So then the 2 solutions are 45 years old and 41 years old. So we knew that something was wrong. Did it change it? Yes, of course it changed it. So parentheses 1.18 plus the square root. I'm doing it again so we can put the answer in. We know it's correct now. I just I missed something in there.
Does that mean that those 2 solutions are
yes.
on either side of the minimum?
Yes. Yes, exactly. So plus the square root in parentheses 1.18 squared minus 4 times A 0.013 times C, which is minus 3, right? Oh, minus 2 now, 26.25. And close the parenthesis and divide by 0.026. So for the other one that it gave me, Everything was fine. As I said, I missed a parenthesis somewhere. So I got 51 and 39. So 39, and comma, and 52. And check the ends. Okay, so that was the issue. So careful with parentheses. I say that all the time, and I wasn't careful myself.
It's almost like an upside down bell curve. Or what we used to call a bathtub curve.
Right, because it has a minimum. The leading coefficient is positive. Yes, very good. Okay, last section. We have this one, 44. Let's take a look. This deals with graphing quadratic functions. So let's choose to graph a quadratic function from scratch. Any quadratic function. And then I would like to look at a couple of word problems if we have time. Yes, we have about 10 minutes.
Can you pick one that has a couple of translations in it?
With the transformations? Sure. Any preference?
One that has at least two.
Okay, so let's say this one. So f of x, 16 minus x minus 2 squared.
So I'm thinking you're going to want us to start thinking about what the base function is. Right?
Yes, so of course the base function is x squared. And the first transformation will be x minus 2 squared, which is right 2. Then we have the minus to take care of. So it's negative x minus 2 squared, which is a reflection with respect to the x-axis. And number 3 is negative x minus 2 squared and plus 16. So up 16. So we move right 2, then we reflect, and then up 16. So the vertex must be 2 comma 16. Is that okay?
What happened to the minus b over 2a?
Very good question. Minus b over 2a is needed only when the square is not completed. But when the square is completed, we use transformations. We don't need to expand to find the negative b over 2a.
So this is like in that minus hk.
Exactly, exactly. So you have x squared. You shift it to your right 2. We reflect, and we move it up 16. So it's a 2, 16. And the range is from negative infinity to 16. So this is the vertex. We know the shape, right, would have a maximum because the leading coefficient is negative. And number 3, will it have x-intercepts? Yeah, because the maximum is 16, right? So max value 16, range is negative infinity to 16 with a bracket. So the x-intercepts, they exist. So I have to write y equals 0. So x minus 2 squared with minus in front plus 16 equals 0. This is cute and nice, I should say, because it's already set up to take the square root after I multiply both sides by negative 1. So x minus 2 squared equals 16, and now we take the square root. So then x minus 2 equals plus or minus 4, or x equals 2 plus or minus 4. And we get the 2 solutions. So we have positive 6 and negative 2. And number 4, we plug in 0. So let's plug in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 with minus in front is negative 4. 16 minus 4 is 12. So 0 comma 12. And 5, the axis of symmetry. It's the vertical line passing through the vertex. So it's x equals 2. So now we can graph. It crosses the x-axis. We should always start with a vertex, but I wanted to see where, so it's 6 and -2. Okay. So 2, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So right here. And here's the vertical, this is the axis of symmetry. These are the x-intercepts. And they have to be at an equal distance from the axis of symmetry. And 0, 12. So 14, 12 right here. And here's the graph. My graph is not perfect. Has to be symmetric with respect to this line, but good enough. Questions? Domain no real numbers, of course. Okay. So I would like us to, I know we have 6 minutes left. I want to finish with the word problem. And that's really the last problem we need to look at. Unless you have questions, of course. Yes, yes. What we covered in class, if you redo the problems we did in class, you should have 0 difficulties. Okay, a ball is thrown upward and outward from a height of 8 feet. So we have the formula function f of x equals -0.1 x squared plus 0.7 x and plus 8. And please find the time to review test 1 as soon as possible. Where x is the ball's horizontal distance in feet from where it was thrown, use the model to solve parts A through C. Part A, what is the maximum height of the ball and how far from where it was thrown does this occur? How do I determine the maximum height? So here's what happens. I throw the ball up in the air, it reaches a maximum and eventually will hit the ground over there. But at first it reaches a maximum and then boom. How do I find the maximum height? What do I need to determine in order to find the maximum height? Of course. Thank you very much. So I need to find the vertex, and I have no choice. I have to find -b over 2a, which is -b. 2 times a, -0.2. So this is like 7 over 2, which is 3.5. How do I determine the y-coordinate? So I'm standing here, I'm throwing the ball up and in the air, and it will reach the maximum 3.5 feet away from me. But I'm interested to find the maximum. Not only how far away from where I'm standing it will reach the maximum, but also what is that maximum? And that will be given by the y-coordinate. How do I determine the y-coordinate?
I guess you're going to put that 3.5.
Exactly. Exactly. This is f of 3.5. I will use my calculator to see what that is. -0.1 times 3.5 squared plus 0.7 times 3.5 and plus 8. I get 9.225. So coming back to our problem, round to the nearest tenth as needed. So the maximum height is 9.2 feet, which occurs 3.5 feet from where the feet from the point of release. Now part B. How far does the ball travel horizontally before hitting the ground? What am I asked to determine? Now I'm standing here, I'm throwing it up in the air, and eventually will hit the ground. So remember the trajectory is like this. What type of function is this? Of course, we know we have the function.
It's a parabola.
Correct. And I'm asked to find this number. What does that mean?
That's on the intercept.
X-intercept.
The only way to cheat and get it would be to maybe look at the
Yeah, but we
distance
have,
down, the
but
distance half the distance to the
right, but we
vertex is half the
that is
distance
true, but that could be confusing for some because it will be negative. So the other one will hit behind me, and it will be a negative number. This way, right? Behind me would be a negative number. So it may be confusing. So yes, but yes, you're right. So y equals 0, negative 0.1 x squared plus 0.7 x and plus 8 equals 0. I will use the quadratic formula, but this time I will definitely not, first of all, I will never solve a quadratic equation with a negative leading coefficient. So now I can, taking advantage of that, I'll multiply by negative 10. So I have x squared minus 7x and minus 80 equals 0. Always remember, I don't recommend you solve a quadratic equation with a quadratic formula with a negative leading coefficient. Negative b plus or minus b squared minus 4ac 320 over 2 times a. With the graphing calculator again. It says round to the nearest tenth as needed. One of them will be negative. So clear. Left parenthesis, 7 plus the square root of 49 plus minus 320. It's positive minus 4ac, of course, plus. So plus 320. Close the parenthesis, go outside, close, and divide by 2. That's one. And the other one will be negative. As expected. So disregard the negative 1. I'm going to write both. So x equals 13.1, and the other one is negative 6.1. And of course, we are talking about feet, so the second one is not acceptable. And I will put it in. So it says how far round to the nearest tenth is needed. So I will put 13.1 and check the answer. And final question, it's asking us to graph. So we know a lot about this. Here's what I know. I know that it starts at 8. 2, 4, 6, 8. I know that the maximum is, so if this is 2, 4 at 3.5, right here. And the maximum is 9. So 8, 10, 9.2. I know that it hits the ground 13. So this is 2, 4, 6, 8, 10, 12, 14. So here's the graph. So now when we look at those options, I'm just done right now. I just want to choose. Let's see, this one cannot go to 10. This one does not start at between 10 and 15. This one is potential, has potential because it's between 5 and 10. Okay, so I'm debating between these two. Not possible because it hits at 13, and this one hits beyond 17. Not possible. So this is the only chance I have. It starts at 8, above 3.5 has the maximum, and it hits somewhere between 10 and 15, and that's the one that I'm going to choose because I determined all the answers. I had all the questions answered. Starts at 0.8. It hits the x-intercept is 13.1 comma 0, and the vertex was given or was determined. So anything else didn't make any sense.